Hello everybody and welcome to our video today where we are talking about organic chemistry chapter 10, nitrogen and phosphorus containing compounds. So a lot of this is review from, biochemistry chapter of amino acids, but we're going to go through it anyways because it is touched upon in chapter 10 of organic chemistry. So to start off, we have the alpha carbon of an amino acid is attached to 4 substituents, which we know. Right, and those 4 substituents are the art group, the hydrogen, the amino group, and the carboxyl group, okay? And we also know that all of them have a chiral stereocenter except for glycine. So they are also all amphoteric, and they are classified by their R group, which we know down here. I'm going to show you guys. Oops. The classifications, I'll just bring you down here to see for a minute. We have the polar ones are glycine, alanine, valine, leucine, isoleucine, methionine, and proline. Then we have the polar ones, which are serine, threonine, glutamine, asparagine, and cysteine. We have the aromatic ones, which are phenylalanine, tryptophan, and tyrosine is a polar one. Then we have the negatively charged glutamate and aspartate. Those are the only 2. And lysine, histidine, and arginine are our basic amino acids, and they have a positive charge. So that's just a quick review. Definitely important to know, for sure. One of the most important pieces of the MCAT for sure is the amino acids. Also, amino acids are formed by peptide bonds. They have peptide bonds formed by condensation. So when we say condensation, it means removal of water. So you take the OH from this group and the hydrogen from this group, and you're going to take away the water, which means between this carbon and this nitrogen, you're going to form a bond, and that is the peptide bond. Next, we go over here. Let's look at the synthesis of amino acids in lab. So we have 2 methods. We have the Strecker's synthesis method, which is formed from an aldehyde. So there's an aldehyde plus NH4Cl and potassium cyanide, and the ammonia attacks a carbonyl, creating an imine. And then the imine is attacked by cyanide, creating an aminonitrile. And the aminonitrile is hydrolyzed by water to produce your amino acid. I would definitely just say know, what is required for this synthesis. And the same thing for this following one. So I might butcher these names of these compounds, but the next is the Gabriel synthesis, which is definitely a little more complex in my opinion, but it's formed from an alkyl halide, potassium phthalimide, and a diethyl bromomalonate, okay? A mouthful. And, I'll read through these steps. Me personally, I don't know if I can necessarily advise you to know this or not. I personally haven't necessarily seen it, but don't take my word for it. If you really want to get all of your content review, there would be no harm in knowing this. But we have the phthalimide attacks the diethyl bromomalonate, creating an ester, okay, a phthalidomalanoic ester. And then that is attacks the alkyl halide, creating an ester with an alkyl group, okay? And again, I would suggest that the most important part is just like the ester, knowing, okay, now we have an ester and alkyl group, so that if you were to see this, you could identify it. And then that product, the ester and the alkyl group, is hydrolyzed to produce phthalic acid, and esters, it takes the esters into carboxylic acids. And then one of the carboxylic acids is removed by decarboxylation. So I know these ones are a little more detailed than what we've done in previous videos, but those are the steps for them. These, the Strecker synthesis and the Gabriel synthesis are just 2 ways to synthesize amino acids in the lab. But again, I would, the most important and the foundation of a lot of other things comes from the classification of these amino acids and being able to recognize them. So hopefully this video was a good overview, and leave your comments below, and we'll see you in the next video.